Hey everyone, welcome to another episode in Physics is Fun. Today is going to be about vectors and their very useful components. And don't worry too much that this problem uses force, something that hasn't been covered yet. Let's jump into reading the question. Two kids are pulling a toy from a dog. The kid on the right pulls with a vector force F sub 1 of magnitude 120 newtons and direction of theta sub 1 at 60 degrees. The kid on the left pulls with a vector force F sub 2 of magnitude 80 newtons and direction of theta sub 2 at 75 degrees. Find A, the single force that is equivalent to the two forces. Or find B, the force that a third kid would have to exert on the dog to make the resultant force equal to 0. This question includes a drawing to help. To make my drawing more simple, my kids will just be triangles and the dog is a circle. There is a kid on the left and the right. The dog is over here and the two kids are tugging on the dog. These dotted lines are the coordinate system. The right dog is tugging with a vector force F sub 1 and the left kid is tugging with a vector force F sub 2. This right angle is the theta sub 1 and this left angle is theta sub 2. I drew in these dotted lines to show the triangles that the vectors make. Remember, vectors can have components, even in 3 dimensions, but for now we just stick with 2 dimensions, the x and y axis. Positive x going right and positive y going up. The vectors will have an x and y component then for both of them. For notation purposes, x is equal to I and y is equal to j. Let's move on to our given variables. The vector force F sub 1 equals 120 newtons, the vector force F sub 2 equals 80 newtons, the angle theta sub 1 equals 60 degrees, and the angle theta sub 2 equals 75 degrees. The vector components are really important, so we need a y sub 1 and an x sub 1, and a y sub 2 and an x sub 2, obviously for each corresponding vector. With our variables set up, let's see what equation we need to solve part A. To find the equivalence of the two forces, we need to add them. To find the vector force F total equals vector force F sub 1 plus vector force F sub 2. We cannot just add the vectors, but we can indeed add their components together, x to x and y to y. F sub 1, x hat, plus F sub 1, y hat, plus F sub 2, x hat plus f sub 2 y hat. To find each component, we can use trigonometry on the vector triangles that is outlined. We have sine of theta equals opposite over hypotenuse, and cosine of theta equals adjacent over hypotenuse. To find our values, we need to multiply across the hypotenuse to get y sub 1 equals sine theta sub 1 times f sub 1, and x sub 1 equals cosine theta sub 1 times f sub 1. And y sub 2 equals sine theta sub 2 times f sub 2, and x sub 2 equals cosine theta sub 2 times f sub 2. With all our components for the equation, it's now time to calculate. Rewrite the vector force total equals f sub 1 plus f sub 2. Now let's substitute our components in to get f sub 1 times cosine theta sub 1, x hat, plus f sub 1 times sine theta sub 1, y hat, plus f sub 2 times cosine theta sub 2, x hat, plus f sub 2 times sine theta sub 2, y hat. I forgot to write my little hats for f sub 2. We now have both vector forces and both theta angles. Substituting in our variables, we have vector force F total equals 120 newtons times cosine of 60 degrees x hat plus 120 newtons times sine of 60 degrees y hat minus 80 newtons times cosine of 75 degrees x hat plus 80 newtons times sine of 75 degrees y hat. After multiplying, our vector force F total equals 60 newtons x hat plus 104 newtons y hat minus 20.7 newtons x hat plus 77.3 newtons y hat. Adding x hat and y hats together equals a vector force F total of 39.3 newtons x hat plus 181 newtons y hat. This is our answer in component form, so let's turn it back into a vector form with a magnitude and direction by using vector force F result equals the square root of f sub x squared plus f sub y squared. Plugging our x hat and y hat in, we get the square root 39.3 newtons squared plus 181 newtons squared equals out to the square root of 34,305.49. Our final vector equates to around 185 newtons. Finding the angle, now we need to use tan theta equals opposite over adjacent, or in this case, y over x. To find the angle theta, we need to now find inverse tan of y over x. Plugging in the values from x hat and y hat, we get theta equals inverse tan of 181 newtons divided by 39.3 newtons. Crossing out the newtons and calculating, we get a final angle of 77.8 degrees. So we have 185 newtons at 77.8 degrees. Let's solve for part B. I wrote the vector force F total under variables. Part B, find the force that a third kid would have to exert on the dog to make the resultant force equal to 0. Well, time to calculate it. Vector force F sub 3 has to offset our other vector force F total, so essentially F total minus F sub 3 equals 0. This means F sub 3 will equal negative vector force F total. So plugging in our F total negative equals a final answer of negative 3.39 newtons x hat minus 181 newtons y hat. So our problem is solved for A and B at 185 newtons at 77.8 degrees and a negative 39.3 newtons x hat minus 181 newtons y hat. I hope these intro problems are as helpful for you as they are for me. Thanks so much for watching. Hope you come back to learn more exciting material, and I'll see you next time.